and I'm going to share my screen. And tonight we are talking about loops. Loops are an extension of branching, which we started last week. We started with if, else, else statements last week. And they add in the ability to reuse code. This is our first introduction to reusability. And why is reusability important? And I'm going to address this a little more when we come to doing functions. But as a professional, for every piece of code that I write, I know that I'm probably going to have to do something somewhere along the line to maintain that. Now, it might not be because there's a bug in the code. Oftentimes there isn't. Sometimes requirements change. Things have to change in the code. And the fewer lines of code that you write, the less maintenance you will have to do later on. And the other reason that's important is that I write a lot of code. I don't remember every single line of code I have ever written. So when I go back in 6 to 8 months, because a requirement has changed, and I have to change that code, I have to familiarize myself with that code again. And so writing fewer lines of code is less for me to have to familiarize myself with. And one of the ways we do that is by making code reusable. The first part of making code reusable is understanding how a loop works and how you can design your code to be driven by the data that's there. We've done a little bit of that up till now. We're going to start doing more of that. So you've already had to work on a paradigm shift up till now, learning about variables and branching, and now we're going to do a little bit more of a paradigm shift, because we're going to start talking about how to make the data drive our code. And so, what is a loop? A loop is a block of code that can be executed again and again and again without having to write the code again and again and again. So you can have one block of code, and that block of code will get executed as many times as you need it to get executed. Now, one thing to think about, and I'm going to bring this up a couple of times in this class, and probably in other classes, or in other sessions. There are two types of loops, loop structures. There's a for loop and a while loop, okay? I use a for loop most of the time in my job. There are instances of when I would use a while loop. For you, a while loop is going to be important because it is the main processing loop for your game. When they're talking about the game and writing that main processing loop, that will be a while loop. So that's something that I just wanted to introduce now, and we'll bring it up a little, as things move forward. So let's, yeah, they're just talking about a loop is a construct. It repeatedly executes the same code, and each loop is called an iteration. And that's just the terminology. When I talk about an iteration for a loop, I'm just talking about the fact that I've gone through the loop code once, or I've gone through it twice. Each of those would be an iteration. So, while loops. This is the first construct that we're going to talk about. And while loops are important for you guys specifically because this is the main control unit for your program. So that's just something to keep in the back of your head, and we'll talk about that a bit more. So a while loop is the word while. While is a keyword. Okay, it can't be used for anything else other than to tell Python you're about to start a while loop. And then there's something called an expression. Now the expression is a test. Okay? After every while keyword, you have to have a test. That's what that expression is. And the test, just like an if statement, has to have either a true or false as the outcome. So if you're dealing with, a test you would take in high school, and they asked you a question and the answer was either true or false, that's what this is. And then there is the lines of code inside the while loop. So it's a block of code that is indented one from the while loop, and it will be executed again and again and again. So I'm going to show you real quick. Oops. I'm just going to create a new file, and we'll just do a quick example. Simple while. And add configuration. I should have done this a second ago, sorry. Python. My computer's getting old and it's not as quick as I'd like it to be anymore. So, okay. All right. So this is a simple while loop. And I'm going to say while, first of all, I'm going to use what's called a helper variable. And this variable exists outside of the while loop, but can be accessed from inside the while loop. So I'm going to say answer equals no. And then I'm going to say while answer is no, I'm going to say print input, so this is just a very simple while loop. Okay, that's all it is. And I'm going to okay, so I have a variable called answer. I know it's a variable because it's on the left-hand side of a single equal sign. I have given it the word no. So that's what it's going to be initially set to. And then I have on line 5 created a statement, and I have said while the variable answer is equal to no. Then I'm going to do lines 6 and 7, and when I'm all done, I'm going to print line 9. So why do I have this variable answer, and why did I set it to no? So answer is a helper variable, and it is also the variable that is going to be used as the test in for my while loop. So the test reads, is answer the same as the word no? If true, I'm going to go in to the loop. If false, I'm not going to go into the loop. So I specifically have answer set to no because I want to go into the loop at least once. And then I'll show you what happens if I change it. So let's just run this really quickly. Actually, we'll debug it. And we'll walk through and we'll see what happens, okay? So here's my debugger console down here at the bottom again. You can see where I am in the Python script because of the blue line. Right now it's next to line 3. And so if I look at the debugger, nothing's happening yet. So I'm going to step over, and now I see that Python has said I have a variable called answer, and it's equal to the string no. Now I'm on line 5, and if we look at this for a second, we know that answer is the string no, and I am checking for the equivalence for the string no. So this means I'm going to enter a block of code beneath. So I'm going to go to line 6, and so now I'm going to say input the answer. So when I step over it, I pause because I have to input the answer, and at this point I'm going to say 42. That's funny if you guys know anything about the Hitchhiker's Guide to the Galaxy. And if you don't, just put it off to the fact that I'm a geek. Okay, so now if I go back to the debugger, answer is 42. I'm going to print what the answer is. Now what you'll notice is after I printed what the answer was, I went back up to line 5. And I went back up to line 5 because this is a loop. I went through one iteration. I have now gone back up to the loop. Now answer has been changed inside of the loop. Answer was changed to 42. So now when I look and evaluate this loop, the question I'm asking is 42 the same as no? Well, it's not. So I'm going to get false. And when I get false, I'm going to step out of the loop, and I'm going to print done with the loop, and I'm done. So that's basically what a while loop does. So I'm going to change this a little bit, and I'm going to say, actually, let me say Q here, because that might make more sense. And I'm going to say, while answer is not equal to Q. Could everybody please mute? So I changed this because I want you to see the difference between how it works when you're testing for equality or testing for inequality. So right now, I've gone from testing to equality to testing for inequality. So actually, I'm going to say yes. So, and what I did is I wanted to make sure that my answer was not Q. So I'm going to put this through the debugger again. And I'm going to step over my first line, and we'll see that answer is Y. So if I'm on line 5, we know I'm on line 5 because it's the blue line, and it's going, I'm going to check and say, is Y not equal to Q? Well, Y is not equal to Q, so that's a true statement. So now I'm going to step into the loop. I'm now on line 6. Step over line 6. It pauses and waits for me to enter. I'm going to enter my geeky 42 again. I'm going to step over. It's going to print the number as 42. Now I'm back up at the top of the loop. I'm back up at the top of the loop, with answer being 42. 42 is not the same as the letter Q. Therefore, I'm going to go into the loop again because line 5, the expression in line 5, did not evaluate to false. It evaluated to true. So I'm going to do the exact same thing again. This time it's going to wait, and I'm going to say the answer is tomorrow. Okay? The answer is now tomorrow. It's going to print the answer. Now you'll notice that I haven't gone to line 9 yet. That's because I haven't broken out of this loop. I am still iterating through the loop. So tomorrow is not the same as Q. So I'm going to go inside the loop. I'm going to ask for the answer. It's kind of waiting. And I'm done with this loop. So now I'm going to type the lower letter Q. It's going to print Q. Now I'm back up at the top of the loop. And answer is now Q. And I'm going to say, is Q not equal to Q? Well, that's not true. That's false, because Q is equal to Q. So it evaluates the false. You'll notice it did not go to line 6. At this time, it went to line 9. So we are now out of the loop. We're not going to iterate over a loop anymore. I'm going to say print, done with the loop. So when I look at my output, I can see what if the answer is 42. That was one iteration through the loop. What is the answer? The answer is tomorrow. Second iteration through the loop. What is the answer? The answer is Q. That was the third iteration through the loop. And because the answer was Q, I broke out of the loop and went to line 9. So that's what's happening in Python when we're looping. And this is what you're going to have to do in your game with that while loop. So that is a while loop. We stepped through the while loop. They have an example of the while loop here. So a challenge activity. Basic while loop with user input. I think basically we just did that. It's just not the same input. Basic while loop expression. Write a while loop that prints the user num divided by 2 until user num is less than 1. Okay, the value of user num changes inside the loop. Okay, so this is very similar to what we did. So I'm not going to go through this one either because basically you're just changing the value inside the loop. You're not doing an input inside the loop. You're you're just changing it inside the loop. This is just the greatest common denominator. They're just doing a conversion thing here. This is all just about changing data inside the loop. Okay, getting input. And if there's any particular challenge you guys want to see that you are having trouble with, let me know. If not, I'm going to continue on, and then we'll look at, I'll introduce a couple of the labs. So, counting in a loop. Counting is important. Now, when I do counting, I usually use a for loop, but it is something you can do for a while loop. So let me show you how to count inside the while loop. So we'll do this. Okay. So basically what we're going to do is we're going to count inside the loop. So I'm going to say counter equals 0 while counter is less than 10, print Okay, this is very simple. This is just a couple lines of code. I have my helper variable again because I need this variable. Okay, this variable exists outside of the loop. And without it, and I'll show you what happens in a second without it, this while statement makes no sense. Oh, I think there's a question. Okay, yes. Counter plus equal 1 is a shortcut, and you are completely right, Christian. I have an old brain, and while I would do that shortcut in Java every time, I started out in Python 2 and the shortcut wasn't available. So when I write Python, I don't always use the most recent shortcuts because my brain doesn't automatically go to them. So you could do that. So what's going to happen here is I am changing the value of counter inside the while loop. And when I run this, I think your brain works just fine. Don't worry about it. So when I run this, what we're going to see happen is counter is, obviously my brain doesn't work either. Okay, so now what we see is counter changing through this loop. Okay, so what has happened, let me move this up a bit, is it starts out with counter as 0 because of line 2, and then it goes to counter is 9 because 9 is less than 10. So let's change a couple things. First of all, I'm going to make this 2. That's all I changed was that number 2. If I run it, you will see that we're starting at 2 because I changed this to 2. Counter is counter. So now what happens if I get rid of this all? Let's see what happens. Okay? Name counter is not defined. So that's why I have to have that helper variable. I have to have that helper variable out there, or while isn't going to know anything about counter. The only way while can know about counter is if I tell it. The only way to tell it is to define it outside that loop. Okay? So that's how you increment a counter, and we'll do this. 1. And it will work beautifully. There you go, Christian. So what I just did is a shortcut. It's shorthand for what I had done originally. It is available in Python 3. Years ago when I started writing Python, it wasn't available, so I don't always use the best shorthand. So that's how you count inside a while loop. Let's see. There are other forms of counting. You can count backwards. So counting backwards is just subtracting, and counting forwards is just adding. And we're going to save a lot of the counting stuff for loops. So this is just print 1 to n, and that's kind of what we just did. And okay, for loops. I do most of my counting in for loops. So a for loop is very similar to a while loop. A for loop, though, is set up to count things. That's really what it's there for. And while you can count things in while loops, it's more efficient to do it in a for loop, because there are things that you get, like ranges and things like that, in a for loop. And also, when we go into doing lists, you can do a for loop over a list without having to count anything. I use for loops the majority of time in my day-to-day job. That doesn't mean I don't use while loops. I don't use them as often. While loops don't have to have a definitive endpoint. Okay? I can wait for a user to input the letter Q. So there's no definitive time when it's going to necessarily stop in a while loop. In a for loop, you usually have some kind of bounds, a range, a list, something. So for loops have a little bit of a different format. With while loops, we had while, expression, and colon. By the way, don't forget the colon. It's going to drive you crazy if you forget that colon. It's the same as if statements. The only way you can tell Python that you are done with the expression for a loop is to put that colon at the end. Back to for loops. So basically a for loop loops over a container like a list. It can loop over a series of numbers. It's very, very handy. Now the syntax is a little different. For is the keyword. You can only use for a for loop in Python. You have some variable, okay? And you can say in, usually. It can be in a range. It can be in a container. And then the colon. And then you've got the body of the loop, which is however many statements you need in that to do whatever it is you're going to do. The example here that they have is for name in, and then they give you a list. I don't think it's really fair to do this at this moment in time because you haven't really gotten into lists. We've only just started to talk about collections, and we'll talk a lot more about collections next week. Know that you can do this, but it shouldn't. There are other things that I think we need to talk about, like creating loops, and this is printing a list. Sorry. So they are going to have you do things with lists. And we did talk about lists in the beginning. Okay, if you're doing this challenge activity for printing a list, where is it? It's this right here, right there. That's the challenge activity. You just have to put the right variables in the right place. Printing a dictionary, they gave you an example of printing the dictionary. Okay. So range. Range is a very handy thing. Range is a function, and the function provides you the ability to go between two numbers. And you can count between two numbers each number. You can count every other number. There's all kinds of things you can do with range. When I'm writing a for loop, I often use range. If I'm not doing a for over a collection, I'm doing a for over a range. And so that's what this gives you. It just allows you to have a starting point and an ending point and how many numbers you jump through. Now, one thing to note here is that range can take several different arguments. It can take a single argument, which always says I'm going to start at 0, and I'm going to end at 1 before the number. So it will not end at 5. This one will end at 4 because you will have done a range over 5 elements because it starts at 0. And that is identical to this range statement. First range statement in this table and the second range do exactly the same thing. The third range, this range, will start at the number 3 and end at the number 6 because it is 1 less than the end value for the range. This is 10 and 13. All of these are great. This is different. This will do every second number. So it will do 0, 2, and 4. It will skip 1 and 3. Pretty good if you only want to do even numbers. This has a -1. This will start at 5, it will end at 1, and it will count down. So it will start at 5, it will end at 1, and we know that it will count down because the counter right here is a -1. And oh, by the way, that's what these parameters are. There's start number, end, and the increment. So I'm going to start at 0. I'm going to end at 1 before 5 because I will have done 5 elements. And I'm going to increment it by 2. I'm going to start at 5. I'm going to end at 1. And I'm going to increment by -1. And I'm telling you this because you're going to have to count down in one of your challenges. So let me do a simple for loop with a range. New. So the simple for loop is, let's do this. Okay, so I'm going to say for counter in range 0, 6. Oops, that's a colon, not a quote. So just 2 lines of code. Now, if we look at this while count here, I had 4 lines of code, okay? And here I have 2 lines of code. Remember when I was talking about writing fewer lines of code? This is one of the reasons I use a for loop, because I can do in 2 lines here what it took me 4 lines to do for the while loop. So I'm going to run this, and you will see down here that it started at 0, it ended at 5. I have 6 complete iterations through the loop, and I did it in 2 lines of code. So now I'm going to change this by just saying 2. So now the increment is going to be 2. I'm going to run it, and I only get 0, 2, and 4. And that's because it's incrementing by 2. It starts at 0. It doesn't go to 1 because it's incrementing by 2, but it will go to 2. And then it will add 2 again and go to 4. Now, here's something interesting. I'm going to start at 0 and go to 6, and my increment is going to be -1. Anybody thinks they know what's going to happen? Nothing. Because 0 minus 1 doesn't ever make it to 6. So Python's going to say, okay, well, obviously you didn't want me to do anything. So that's just a couple of things to think about. So while versus for loops, I think I've covered this pretty good. Nested loops, okay? You can have loops inside loops. You can have if statements inside loops. You can have loops inside if statements. You can combine these any way you want. They have this example 2-letter domain names here. And what you need to remember is what's inside which block. Okay, because when you look at this example, you have an outer block, which is this whole thing, and then the inner block, which is this. And you have to understand that they are, the way they work is that you get to the inner block and you run the inner block until it's done, and then you go back to the outer block. So let me do this. I'm going to do nested for loops. And we'll look at an example. Nested for loops. So I'm going to say for outer in range 0, 5, and then I'm going to say for inner in range 0, I don't know, let's do this. We'll do 5 to 10. Okay, and then I'm going to print okay, and I'm going to change this up in just a second. But I'm going to run this. And then I'll also do one with a nested while loop in it. So I'm just going to run this, and you're going to see something very different. Okay, it says outer is 0, inner is 5. Oh, I guess I needed to put a space there. Outer is 0, inner is 6. Outer is 0, inner is 7. Why in the world isn't outer changing? Because I haven't gotten to that place yet. So let's debug this. Let's walk through this. So I'm debugging it. I didn't need to stop at 2. Outer is currently 0. And now I'm at inner. Inner doesn't have, you'll notice it doesn't have any value yet because it hasn't actually been created by Python until I step over the code. So I'm going to step over the code, and now inner is 5. And so I'm going to print, so I get it to print to the console, and then I'm going to go back to the debugger, and it's now, as you'll notice, it went back up to 3. It went back up to the inner loop. It hasn't touched the outer loop again. Okay, it's still inside this outer loop. But it's going for inner, and it's now going to evaluate inner again. And so I'm going to go over inner, and inner is now going to be 6, and I haven't hit the outer loop again. I'm still at the inner loop. And now inner is 7, still haven't hit the outer loop again. Inner is 8, still haven't hit the outer loop again. Probably you're getting sick of hearing me say that. Now I'm at 9, okay. Now remember, for the inner loop, we go to 10 minus 1. So we're only going to go to 9. And so Python says, oh, I am at 9. I should be at 10 minus 1, which is 9. And now it goes to the outer loop again. Outer is 0, but we know, Python knows that it's time to increment it because it's back up at the top of the loop. Outer now becomes 1. And back at the inner loop, I start all over again. Inner is a brand new variable. Okay? As far as Python is concerned, once it hits that outer loop, inner becomes 5 again. Okay? It just does. That's the way looping works. So I'm now going to go back through all these. Outer still hasn't changed from 1. I'm now back at the outer loop, and we're now outer is 2. So that's an indication of what happens in a nested for loop. Now I'm going to show you a little bit different syntax, because some people, when they do nested while loops, have problems with the helper variables. And by the way, for those who asked for a little bit of more insight into nested loops, let me know if I'm on the right track and if this is what you need, or if you need something different. So I'm going to just stop this guy. I'm going to create a new file for nested while. So with a while loop, if we're counting, we have to have a helper variable. Well, we always have to have a helper variable. So I'm going to call this outer helper, and I'm going to say it's equal to 0. I'm going to say while outer helper is less than 3. And then I'm going to have inner helper. I'm going to say inner helper is 0. And I'm going to say while inner helper is less than 3. And then I'm going to print outer helper is inner is format. Now notice again, because I'm going to harp on the difference between while loop and for loops. In the nested for loop, I had 3 lines of code. In the nested while loop, I have 1, 2, 3, 4, 5 lines of code. So while is great for some things. You shouldn't use it for counting. But anyway, I'm going to run this, and okay. So I'm just going to run nested while, and you will see something very similar. Oops! No, you won't, because I forgot. Anybody know what I just did? I just messed up and created 2 infinite loops. And the reason I did that was because I wasn't paying attention to what I was doing, obviously. So I did not increment my counter. So I actually have to have more lines of code. Notice in the nested for loop, I have 3, and I don't have to increment anything. Here, I'm going to have to say inner helper plus equal 1. And then I'm going to say outer helper plus equal 1. So now I have even more lines of code. This is so that I increment. So outer helper is outer helper, and you'll notice the difference in indentation. All right? Line 5 will be executed when I'm in the outer loop, and line 9 will be executed when I'm in the outer loop. Line 7 and line 8 are going to be executed when I am inside the inner loop. So now let's see if I can not do infinite loops again. And there we have it. So I have outer helper is 0, and then you'll see the inner helper changing value. And then you will see outer helper is 1, and inner helper is changing value. And outer helper is 2, and inner helper is changing value. So the concept of inner and outer loops, and the reason I use the variables inner and outer are to indicate what's an inner loop and what's an outer loop. So also notice that outer helper is available to, never mind, that's not, what I was saying wasn't going to be right. So does this answer the questions about nested loops? Okay. So let us go and take a look. Are there any particular, if there's any particular labs you want me to go over, let me know. Incremental programming. And we're starting to get, the reason they're going over this in zyBooks labs tonight, or in zyBooks tonight, is because we're starting to increase the complexity of our programs. So you really do want to do what they call incremental programming. I call it baby steps. You break down the problem into very small chunks, and you solve a small chunk, and then you test it. When you're happy with how that works, you solve the next small chunk, and then you test it. And that is how you build up a working quality program. Okay? And that's also important because your zyBooks labs are about to start getting more complex. Okay? So, break and continue. So there are ways to stop the execution of a loop. There is just stop and don't do anything more. So stop the loop. I've made it to a condition, I'm going to stop. And then there is continue that says, I have a condition within the loop and I don't really want to do anything with that condition, so I'm just going to go tell it to go right back up to the top. So that's what break and continue is. And break is an exit statement. The only reason they don't use exit is because exit is used for something else in Python. But break says just don't do anything more in the loop. So when would you use a break? Well, you would use a break statement if you had a conditional. So when you look here, and I want to use this example specifically because it is a complex example and because it has nested loops. So what we're seeing is we have two loops. We have number of tacos and number of empanadas. And we want to regulate this by the cost of the meal. Okay? So if the cost of the meal is the same as the user money, then break. So get out of that loop. And then check it again if the cost of the money is the same as the user money. Then break out of the outer loop. So you'll notice there are two break statements. They check the same thing. One for the inner loop and one for the outer loop. And that's important that you understand what you're breaking out of, what you're exiting. Some students do a single break statement and they expect it to exit out of both the inner loop and the outer loop, and it doesn't work that way. You have to explicitly tell Python which loop you're breaking out of. And continue is similar, except continue takes a condition and it says don't stop the loop, go back up to the top. Don't do anything else below this. No other lines will be executed. Go back up to the top of the loop. And so let's do the Simon Says challenge as an example of those. So, and then what is this? This is challenge 4.10.1. Oops. 10.1. So what is this? This is Simon says something. We'll just copy all this. Copy all that. So it's a memory game where Simon outputs a sequence of 10 characters, and the user must repeat the sequence. Create a for loop that compares the two strings. For each match, add 1 point to the user score. Upon a mismatch, end the game. Okay? So the sample output with inputs. So that's the input, that's the output, and the user score is 4. So that's just an example of what they want you to do. But it can be any sequence of those characters. So I'm just going to do this. So we have a user score of 0. We have Simon's pattern and the user's pattern, and then they want us to print the user score. So what are we going to do? Well, the first thing we're going to do is we're going to ask the user for their input, for the Simon pattern. And the second is the user is going to give us a pattern. And then what we need to do is, we need to do a while loop. While is not the same as user. All right, sorry, hold on. Nope, that's not what I want. No. Actually, we're just going to do a while true. Sorry. So I'm just going to tell this while loop to run forever until the user gets it wrong. So what I want to do is I want to say if Simon pattern is the same as, is not the same as user pattern, break. Else, user, actually we don't even need no. User score plus equal 1. And then we're going to say user pattern input. So this is very simple, and it shows us the use of a break statement. And that's really why I wanted to do the challenge, because I wanted to show you the use of a break statement. So if I run this, it's waiting for the Simon pattern A, B, C, D, E. The user pattern will be A, B, C, D, E. It's asking for the user pattern again. 1, 2, 3. And my user score was 1. So that's what that did, and unfortunately, because of the way zyBooks works, and I didn't add the input here, that it was waiting because it was waiting for me to input this. But when my input was different than the Simon input, it got to this line and it broke. That's how it stopped, or otherwise it would have just kept on going. Okie dokie. Loop else. I never use a loop else. I will introduce the concept here, but I've never actually used this. in practical programming. And basically what you can do is if you don't end up going into the body of the loop, then there's one other thing to do, and that's what's in the else. So it's like an if-else, except you use it for loops. It's a construct you can use. I've never found it useful. So getting both the index and the value when you're looping. So this has to do with using the enumerate function. And so sometimes you need both the position, the index in the list, and the value in the list. So you can you can use the enumerate function to get at that. So the syntax is, it says for index comma value in. So instead of just having a single variable here, you have two variables. You have the variable index and the variable value. And the enumerate function will say, take this list and get me both the index and the value. And that's what the enumerate function does. It's handy. You won't really need it in this set of challenges. You'll need it, and it will be useful. You won't necessarily need it. It will be useful in the next module. So this is just dice statistics, rolling a die and what happens. So this is the lab for count input length without spaces, periods, or commas. So what you're done here is you're given a text as an input, and they want you to use a loop, and they want you to make sure that you're not going to count spaces, periods, or commas. So this is something where you could use a for loop. You would do it over the length of the string, and you could simply count based on whether or not it was a specific character. So let's just introduce this one. So this is what lab, what was it? 4.14. 4. And so basically you'll have a string. And this, of course, isn't identical. You're going to have to fix yours. This is a string with a space. So if I am trying to count, I'm going to have my counter. I'm going to start it at 0. I would say for car in stir if car is equal to a space. Continue. And this may not be the most elegant code. You probably are going to want to change this. Otherwise, counter equals counter plus 1. So if I run this, now again, this isn't the answer to it. It is an introduction to what the basic premise is for this lab. So if I run the lab, I have 23. So now let's debug it and see if I actually hit that statement. So, and I did. I'm now on the continue because on when counter was 0, 1, 2, 3, 0, 1, 2, 3. When it was 4, I hit a space. And then, oops, cancel. And then continue. Okay. Is semicolon the same as, hold on, is the semicolon the same as the colon? No, semicolon is not the same as a colon. Did I put a semicolon someplace? No, I didn't put a semicolon someplace. So, continue. Oh, ignore that. I apologize. I was just writing in Java. Line 8 was a valid Java statement. And luckily, Python didn't get irritated with me. Thank you for catching that. So I didn't need that semicolon. I was reading Java today. I was writing some Java today. So that happens occasionally. I apologize. I did not need the semicolon. Introduction to Java. Yep, that's what it is. Okay, so password modifier. This one can stump students sometimes, and we'll go over it a bit, but you have everything you need. So many user-created passwords are simple. They can guess them easy. So they want you to replace characters using the keys below by appending Q star F, and by appending Q star S to the end of the input string. So I have a string, and as I'm going through that string, I want to build a new string. But every time I come to an I want to use an exclamation point. Every time I come to an A, I want to use an at, and so on and so forth until and then at the very end, I want to do Q star S until you have figured out your password. So this would be a for loop. You would do a very similar to this. You would do a for char in stir, and then you would simply replace. So instead of if char is a space, you would do if char is an I, and then add that to your string, because you can just append to the string. If it's an A, then you would do the same thing. So this is very close again to what you need to do for challenge 4.15. So it is simply, instead of skipping a space, you're going to replace a character, and you're just going to create a new string in the process. Okay, so drawing a right triangle. This tends to throw people, but really what you want here is this is nested loops. Okay, this is absolutely a nested loop. So what you're doing here is your outer loop is the number of rows, and your inner loop is the number of columns. So if you're going to use the % character and 5, you would have an outer loop that goes from 0 to 5, and you would have an inner loop that goes from 0 to 5, and it would print a character. So if we're looking at that, and let's see, nested for. This is our nested for loop. Okay, we've already looked at our nested for loop. This is what you need for that lab. Okay, you're going to have an outer loop that goes from 0 to 5 or 0 to user input. So it's going to be whatever the user input is. So instead of 5, if I had, let's do this. So, and then here, I would just substitute that with val, and let's just do that here, 0, val, and see, this is nested for. Let's go back to nested for. And then if I run nested for, I'm going to input a number. That number is going to be 3. And, okay, hold on. So, oh, don't do what I just did. Make sure you convert the string into an integer. And now I'm going to put in 3. And you'll see it outer is 0, 1, 2, outer is 1, and then 0, 1, 2. And so instead of this print statement, you're going to want to print the outer and then the inner. So you're going to want to make sure that in this case you would print outer and then you would print inner. Let's do 3 again. And so then you're going to have to figure out how to end the print statement. So this was something we did in Module 1. And it becomes a little clearer. So this isn't the exact answer. This is a beginning part of the answer. And so you need to make sure that your answer is appropriate and correct. But this is the basic gist of that particular challenge. So, Mad Libs. Okay. All right, so basically this is just somebody gives you a set of inputs and your output is, you know, eating 5 apples a day keeps the doctor away, eating 2 shoes a day keeps the doctor away. So that's all this is. So yeah, I think that one's pretty clear. So does anybody have any questions before I call it a night? Okay, I guess I'm going to call it a night then. This should hopefully be up tomorrow for my students, and I will send out the I'll send out the announcement to the other IT 140 professors. And so everybody have a good evening.